Thank you for joining us today's Minitab webinar. Topic is Minitab for Quality Initiative in Service Industry. I'm Nur Surawati and I'm Technical Support Specialist at Visit System. Visit System is an independent local representation for Minitab product and training in Malaysia, Singapore and Batam, Indonesia. Okay. Before we get started, there are a few housekeeping items to take note. If you have questions during presentation, please type them into the question box in your control panel. You may send in any time throughout the presentation, but I will address them during Q&A session at the end of webinar. Kindly ensure that you have connected to the audio via your computer speaker. Please fill out our survey before you exit the tab. This survey will help us to improve the quality for our upcoming webinar. For your information, this webinar will be recorded and therefore it will be set listen-only mode to avoid interruption to the audio recording. So the recording will be accessible anytime later on our website www.visit.com or by subscribing to our YouTube channel, Minitab Malaysia and Singapore. Okay. So Minitab was developed in 1972. Day one is the statistical software. Everyone can use, whether you are statistician or non-statistician or you're not a data scientist. Okay, since easy of use, we have powerful visualization to help the data-driven decision company. So now with the new release, Minitab Statistical Software 20, in last 22 October 2020, we able to use Minitab from everyone on the cloud version. Okay, so Minitab will be your partner in analytic journey since we have a comprehensive set of statistics for data analysis and for example, in quality side, we have a measurement system analysis. We have a case study where you want to study on the accuracy and precision, and then we have a control chart where you want to study about the process is it stable or not stable, and then we have a capable. Once your process is stable, you go to assess your capability. Is it capable or not capable? And then for the process development, maybe you are coming from the R&D side. Okay, so so when your process is capable and consistent, we can move to optimize process setting with the design of experiment. Minitab will not limit for factory design only, but we also have another design like screening design, response surface, and Taguchi method. So from this analysis from the design experiment, we can identify the critical factor and optimal setting to meet our specification. Another side, we have also like process reliability engineering. Okay, so this one is as the quality of the product over time, and statistically speaking, it is probability of product not to fail during the defined period of time. So we able to do the reliability engineering. So nowadays we talk about the analytic. So starting from the Minitab 19, actually we move on to the enhance our capability on the analytic side. So now we have a correlation, and then the new updating, we have a predictive analytic for CAT. This one is a classification and regression tree. And then we also if let's say you are coming from machine learning, you can hear about the unsupervised. So we also have unsupervised model like multivariate or PCA. And then if let's say your data is in time order, let's say days, hours, minutes, monthly, so you can go for the time series. For your information, in Minitab we have up to ARIMA models. And then if let's say you want to do the process validation part, we also provide the tools inside the process validation. As we know, we in the process validation part, we have process design, we have process qualification, and then we have a continuous process validation. Okay, so this one is our customer, not limited to the manufacturing. We also have the customer from the services like Russia. We also have a customer in academician, okay, so from the university in Singapore and Malaysia. Okay, so we go for our main webinar today. Okay, so it's about the initiative quality in service sector. So in measure quality, the most important here is consistent. Okay, consistency is a vital part of delivering good process product and services. And then to tackle this consistency, maybe we can use statistical model helps to measure, verify, and ensure consistent service quality over the time. So during this webinar, we want to explore with this graphical analysis where we want to find or why we want to identify the main opportunity to do the improvement process. And then after we know, we want to assess the association between each variables. And then after that, we want to measure the consistency about the correctness. And then after that, we can go for the verification our process using the control chart. So in 1 hour, we can cover all these photos. Okay, so quality initiative have been successfully deployed in this various industry over the past 30 years. In service industry, quality measurement is challenging since it's likely dealing with the intangible product and direct involvement of the customer when service is delivered. In many cases, data measurement in service industry tends to be qualitative or attribute data in nature. So if let's say you are coming from the manufacturing side, so no worries. Today we want to focus on this type of the data, qualitative or attribute data in nature. So if let's say we consider that service industry is something like healthcare industry, banking industry, financial industry, hotel and education, okay, and so on. Okay, so for the qualitative attribute data is something like you want to classify or categorize your data. So in the qualitative or attribute data, we have a 3 type inside there. We have a binary, which is you have a mutually exclusive categories like have 2 options, which is right or wrong, true or false, or accept or reject. Or we have a nominal, something like you assign the individual items to a name category that's as nature and then no ranking, something like type of defect, color, something like color is yellow, green, you assign for your variables. Or something like ordinal, something like is scale Likert, let's say 1 is not satisfied, 5 is satisfied, 1, 2, 3 low, medium, high. So we consider that is ordinal. So in do it, they classifies your variables. We have a 3 type. So binary, nominal, and ordinal. The binary, meaning that you have the only 2 options accept, reject. And then nominal, you have something like color or type of defect. Or ordinal is something like Scarlet Likert or rating 1 until 5. 1 is the worst, 5 is the good, something that one is we call it ordinal. Okay, and then we want to get starting our analysis with the graphical analysis. So graphical analysis allow to quickly learn about the nature of the process to better understanding the sources of variation in the process data. So today we want to try with the chart and diagram with the qualitative data, which is if you want to explore with the pie chart, bar chart, and then Pareto chart. Maybe Pareto chart is a quite new for those are not involved in the quality side is a Pareto chart. So, but today I want to show pie chart, bar chart, and Pareto chart inside the graphical analysis. Okay. So now we have a story about the quality team. Notice a high frequency of mistake on the shipping address. They record mistake reported by customer. The company sent out approximately 310 invoice during the period, and then they found 141 mistake. And then they wanted to analyze the type of mistake, the frequency of occurrence, and the people entering the invoice. So meaning that now they have a variables like mistake, the frequency, how many, and then they have people entering the invoice. Meaning that is employee inside do it the invoice. So we directly go to the data set first. Okay. So once you open the Minitab, actually you can see that we have a lot improvement from the 80 to 90, and then now is we call it the 20 version. Okay, so we have something like invoice here. Sorry. Okay. So you can zoom in, zoom out for the new version, right? So here we have a date, we have person is considered as employee to do the invoice, and then we have a type of mistake, and then we have the day. So now we want to know which mistake is the highest done by to the person. So we go for the first analysis with the pie chart. So go to graph. Okay, go to graph, and then you see that is a pie chart here. Okay, so I will go to graph, go to choose pie chart. Okay, so we choose the count of unit. So we here want to assess on the mistake only. Okay, you choose mistake, you go for the labels. So you choose slice label. So now I want go for the percentage only, and then click OK, and then click OK. Okay, so now you get the pie chart. So I will go to graph, go to pie chart, choose the chart count of the unit, and then choose the variables here is mistake, and then you choose the labels, you choose the slice label, click on the percent, and then you click OK, and then you click OK. So you get the pie chart mistake. In this pie chart mistake, you see that the highest mistake is about the pricing variables, and then the lowest mistake is about the quality. So you can see that is red color here is about the 34%, and then the lowest here is 70 is for the quality. So you can see that this one. So I go back to this data set again. So now we know the highest type of the mistake is about the pricing, but is it have a something like relationship between the day or between the person? So we go to the another analysis part. Go to graph, go to bar chart. Okay, go to graph, go to bar chart. You choose count of unit values. You choose the stake bar chart. Since we have two variables, okay, so click OK, and then you choose the first is the day, and then mistake. You choose two here, day and mistake, and then you click OK. Okay, you click OK. So now you get the stacked bar chart. Okay, I will go to graph, go to bar chart, choose counts of unit values, you choose stacked, click OK, you choose day and mistake, okay, and then you click OK. So you get the chart of mistake of the day. Okay, so you see that here is something have a variation. Okay, a lot of have a variation. So we go for another one. We want to do the same graph. Okay, the same graph. We just choose using the features inside the graph. Right click. You see that we have a make similar graph. Different variables only. Here we choose the person. Okay, we choose the person, and then you click OK. So now you get the new you get the new uh, stacked bar chart. Okay, with the new features here. Okay, I not think it's the new one. Since the 80, I think we already have these features. Right click on that, and then you choose make similar graph, and then you can do it. This just okay. So you can get the thing. Okay, you can get the person here. Is a person. So from here, we can see that we have something like a person, and then if your quantity. So you can see that this one is the mistake. Okay, the mistake one. This one is this one. Okay, so you can see you can using our features like make a similar graph. Let's say you want to produce the same graph but different variables. Okay, same graph but different variables only. Okay, so we go for the next thing is we want to find out about the Pareto chart. Okay, we can see that we have something like variation here. So you see that is in the person here is something like have something have this one is association between person and then mistake here. Okay, so we go for another graphical analysis, which is a Pareto chart. Okay, as we know, is a Pareto chart is to identify the most frequent defect for Pareto chart and how to focus which improvement effort where is the largest gain and can be made. Okay, so we go back. Today I want to show how to do the Pareto chart in using the assistant. Okay, assistant is something like automate to you. Okay, is not all the function in the start menu in assistant menu, but it have a frequent customer using, so we insert to the assistant. The good thing for assistant is something like which is help you if let's say you are the new one using the software, using want to do the analysis, or if let's say you are really senior, really have knowledge about that, but want to do just refresh again. Okay, for example, here I go to assistant, I go to the graphical analysis. Okay, you can see that here, what is objective if you want to using the graphical analysis from the distribution, you want to equate the overtime, or you want to have a relationship between the variables. But today I want to go for the Pareto chart. So if let's say you create the Pareto chart here, I have not the summarized value, but I have an observation. So our defect here is our mistake. Our X here is the person. Okay, and then we choose the do not combine. Click on OK. So now we get the Pareto chart. How we do? Go to assistant, go to graphical analysis, and then you choose Pareto chart. Okay, and then you choose the each defect observation. We choose the mistake, and then we have a X variable here is percent, and then you click OK. So you get the Pareto chart from the assistant menu button. Okay, but for most interesting here is in the Pareto, using the assistant, they give it you summary report, which is the Pareto here, and then we also have this diagnostic report. Okay, this one is to help you about the pattern inside the graph itself. Okay, and then we have a summary statistic report here, and then we have the report card. So if let's say you're using assistant, almost all these tools inside the assistant, they provide you summary report, diagnostic report, and then you provide the summary report. And the last part is they provide you the report card. So the report card is something like assumption for that analysis portion. Okay. And then okay, so from this Pareto chart, you can see that person A made a more product mistake than the pricing. Okay, than the pricing, and the less address. Okay, less address than the quantity. But the person C, you can see that is a less uh, is has the product mistake as the quantity. Okay, mistake, they have a many address in the mistake. So they have a contradiction between person A and person C. So that one is we more accessible for us to know further about this variable, which is it have the correlation or association between A and person, and then type of mistake. So we need go further to this portion. We need go further. Another portion is chi-square testing. If let's say you are coming from the statistics background, is something like Harvard testing, okay, or correlation. But today we focus on the qualitative data set. So we go for the chi-square. Is something the same thing, but here we using chi-square to assess the association between categorical variables. Since we know in mistake we have pricing, we have the quality, we have a product, and then for the person we have person A, person B, and person C. For information in the chi-square, we have a three inside the Minitab. Well, first we call it the goodness of fit, which is you have only one variables. But if let's say you want to assess on the association, we have two tools inside there. We have a chi-square test for association, or we have a cross tabulation and chi-square. Okay, but for this case, because we have a mistake type, we have a 4 inside the mistake, 4 type of mistake, and then we have a 30% in the percent. So we go for the cross tabulation and chi-square. Okay, so I will go to the Minitab directly. Okay, so for this one, the same case study now. Based on this Pareto chart, we see that have a associate between a mistake and then percent. Okay, so we want to further this study about this by doing the chi-square testing. So go to stat, go to tables. Okay, chi-square inside the tables. Go to stat, go to tables. So you choose cross tabulation and chi-square. Okay, I will go to stat, go to tables, choose the cross tabulation and chi-square. You choose here. So the row here is our mistake. Okay, the column here. The rows here is mistake. The column here is the percent. Okay, so you go to chi-square. So you choose the chi-square test. Expected cell, and then each contribution. Click OK, and then you click OK. Okay, so you get this one. I will go to stat, go to tables, go to cross tabulation and chi-square, and you choose the mistake for the rows, columns for the percent, and then you choose the chi-square, and you choose chi-square as this one is expected, and then you click OK, and then you click OK. So you get the cross tabulation, okay, or something like pivot table. Okay, and then here is our chi-square. So same goes for the hypothesis testing. Also, we rely on the p-value here. So since the p-value here is less than 0.05, so we consider that type of mistake have associated with the person. Okay, have association between each variable, between type of mistake and the person. So based on this value also, we can see that in the table, we can see that the highest value of the contribution to this chi-square is 3.79, and then for the quantity, okay, for the quantity here is 2.6645. So based on this, I think. Okay, so based on this output, we can see that person A and C had the highest contribution to the chi-square testing based on this value. So you can see that A and C. So person A made more product mistake and the fewer address mistake than expected value. And then for the person C, take the reverse thing. He or she made more address mistake and fewer on the product mistake than expected. So we accept that have a correlation between mistake and then the person. So you need to go further, find out the next stages. Okay, how you want to assess that person. Okay, so this one is the how you want to do it, the analysis regarding for the qualitative data set. So the same thing with the quantitative, but maybe different testing only. Okay, first we go for the pie chart, and then we go for the bar chart to see which variables is most important here. So based on the day and based on the mistake person, so person have more variability, so we more interest into the person by the mistake. We want to have more significant on this statement, so we go for the chi-square to confirm it. Is it have association between two variables here? Okay. So after that, we go for the next analysis, which is attribute agreement analysis. Is let's say you are measurement system, you rely, before this you rely on the gauge R&R, which is you on the repeatability and dispersibility. But today, because our data is a qualitative or attribute data, accept or reject, something rating, so we need have another tools, we call it attribute agreement analysis. So every day we need to make a judgment, okay, when the two or more people have contradicted SSE effect inconsistent delivery of our service. So attribute agreement analysis use data to understand how different people access on particular items, attribute how consistently the same person access on the same item, and then we want to compare both the right assessment. Okay, so in the attribute agreement analysis tell us whether and where we getting it wrong. Okay, to make a better and more consistent judgment. So which is we want to study about the consistency between in appraiser, between appraiser and the standard. Okay, so in here we have a case study here. A busy loan officer, a major financial institution process many applications each day. So a team of 4 review, inspect each application and categorize as is approved or rejected. The loan officer began notice that the inconsistency in approving application. So the bank decide to conduct the attribute agreement analysis for reviewer on that application. Okay, so we have four reviewer. So for each reviewer, they have a 30 application. So every application they repeat for 2 times. So I go to that data set. So we have a new review. Okay, so we have here. So we have 4 appraiser: Javier, we have Jill, we have Jim, and we have Julia. And then so every appraiser here, they have a 30 application. So every application they need to do 2 times of review. So the total of this experiment, we have a 240 experimenter. Okay, so they provide the standard for each review, for each application. So here is our result. So in the Minitab, we have a 2 way to do the attribute agreement analysis. The first, we go for the start menu button. We use the start menu button here. So go to start. Where is the attribute seems? Here in the quality tools, and then you can see that here is attribute agreement analysis. Okay, attribute agreement analysis. So you choose this one. Okay, I will go to start, go to quality tools, go to attribute agreement analysis. So in the attribute here, we have the result. Our sample is applied. Appraiser is our appraiser. Here is a test sample. Okay, so since we have a standard here, so you choose the standard and you click OK. So now we get the result for the attribute. We do go to start, go to the quality tools, go to attribute agreement analysis. You choose the result. Okay, you choose the result. You choose the sample here. You choose the appraiser. You choose the standard. If let's say you have a standard here, and then you click OK. So you get the attribute agreement analysis. So for information in this analysis, okay, in this output, we assess on the within the appraiser itself. Okay, we have the each appraiser versus the standard, and then we have a between appraiser, and then we have the all appraiser versus the standard. Okay, so I think easy to see the explanation here. Okay, so since it's a lot of output in the output section, so basically we want to assess in the attribute agreement analysis is about the consistency of the response for each review. And then we want to assess about the correctness of the responses for each review, and then we want to do the consistency between the review, and then we want to assess the correctness of all the reviewers. So we go one by one. The first thing we say that for the within appraiser. So based on this, not all the review consistently review for each sample of the loan application. So you can see that this one is the matches of the they done it. So not because they need to inspect for 30 application, but now for JBL, for example, only have 21. So the percentage here not almost 100. So not all review consistently review for each sample of the application. Okay, maybe here is a Jim is the highest percentage, and then meanwhile the Julia is the lowest percentage here. And then we have something statistical measurement for the attribute agreement. We call it kappa. Okay, kappa value. So kappa value is if let's say the value is 0 until 1, so 1 is the best. Okay, so 1 is the best. But based on the AIG standard, when kappa value is higher than 0.75, indicate the good agreement. So for this case, is a Jim only have the highest 0.75. So we consider that review from a Jim was a good, since the kappa value is less than higher than 0.75. The rest is less than 0.5. So it's not considered good agreement between for Javier, Jill, and Julia. So this one is consistency of response for each review. So meaning that use every reviewer here, they need to review for 2 times. So for every time, the consistent for the gym only 93.33% only. Okay, so meaning that if let's say they have 100%, 100, so meaning that they have a judgment for every tire is the same. Okay, and then this one is the correctness of response for each review. So gym, again the same thing, gym have the highest percentage, while Javier is the score lowest percentage and the correct review on the loan approval. So this one is they compare from their reviewer to the standard. Okay, so you see that here is comparison between review only. So this one is the reviewer to the standard. So here you see that James is the highest again, and then Javier is the lowest. Okay, and then Javier accepted the bad loan 20%, while the rejecting the good loan 70% of the time. So you can see that is here is assessment disagreement. So you see that here is Javier accept 20%, while rejecting the good is a 70%. And then the kappa for jail is 0.8. Okay, and then the gym is more than there was is a good agreement for the jail and gym. Okay, jail and gym have a good agreement between the review and then the standard one. Okay, and then here is a consistency of response between reviewer. Okay, so only 12 loan application were matched with each reviewer, so it's not good one. Okay, the kappa value, so you can see that this one is kappa value is less than, so it's not good agreement between a reviewer itself. Okay, so for the correctness of the all review, so we have rely on the all reviewer versus the standard. So all review correctly match the standard rating on the 12 only out of 30, so which is only 40%. The overall value is 0.68, so it's a less, it's not so good agreement. So they conclude that they provide additional training for Javier and Julia, and also conducted a general review session for all the reviewer to refresh their understanding about which factor on the application were most important here. So based on this review agreement analysis, which is you want to rely on the consistency of response for each reviewer. You want to have checking about the correctness versus the standard. Okay, you can see that the standard and then the consistency between the reviewer itself, and then the correctness between all the reviewer. So you can get, if let's say your data is a qualitative data set. Okay, and then we have another way to done the attribute agreement analysis, also using the assistant menu button. But before we go there, before I show that, I need to have a stress here. If let's say you want to using attribute agreement analysis using the assistant menu button, you need have your binary response only. It's not applicable if let's say you have a rating, let's say 1, 2, 3, 5. No, assistant menu only for the binary response only. And then for information in assistant, they not provide the between appraiser agreement. Okay, and then also in the assistant menu, they not provide the K value, which is they not provide the kappa value. So they not provide the kappa value for this, for the assistant. So and then the more here is a define each replicate as one opportunity for a mesh. I will show after this what is the meaning for that thing. Okay, so for example here, okay, so now we see that is the appraiser, okay, they need to do 2 times. So for the assistant, they consider that there's only one opportunity for between 2 trial. Okay, for 2 trial it's the same, only one. But for the menu button, they consider there's only one individual. How many times you do it? So how many trial you do it? But for the assistant, they rely every review only one trial. Even you do it more than one opportunities. So that's why maybe have something differences between value between from the step menu button and then the assistant menu button. So we can see that. So if let's say here, go to assistant, you choose measurement system analysis. Okay, you choose attribute agreement analysis. And then here is our appraiser, trial. Here is a result. Here is the standard. Here is the test item, and then present that is our result. And then what is want to acceptable item? So here, of course, we want to accept. Okay, and then click OK. So I will do go to assistant, go to measurement system analysis, and then you choose the attribute agreement analysis, and then you choose the appraiser, and then you choose the test, and then here is a accept, and then you click OK. So you get this result. Okay, so from here you can see that is the overall percentage accuracy acceptable. So only 80.2% the accuracy of the percentage. And then they provide you the overall rate, and then the accept, rated, reject percentage. So mixed rating, the reject, accepted. And then here they have accuracy of the appraiser. You can see that is a gym here. So if let's say I will compare with this one. Okay, compare this one. Maybe have differences between this one. This value. Okay, so you can see that is the differences between this value and this value, because that thing, every trial for the assistant just only assume that for the step menu only one. Okay, but for attribute how many, so they will consider that how many trial you do it. Okay, so individually, this one is a pairing. Okay, this one is individually, this one is a pairing. So this one is the differences between using the assistant menu button and then stack menu button. But I think if let's say you want to follow AIG standard for the attribute analysis, I suggest using the assistant in the attribute agreement in assistant menu button, because they give it the same result as per template in the AIG standard template. Okay, so they will have attribute agreement analysis, how many had the rejected. Okay, the appraiser reject, the standard one is the accept, and then the mix between to both sides. Okay, so they give it this place. Okay, and then they provide the report card for the assistant. So if let's say you want to do the as per AIG standard template, so you merely check with the assistant menu button. Okay, so we need go another tools. I think okay. So the last portion is about the control chart. So control chart a graph that plot your process data in time order sequence. Okay, so from the control chart, actually want to separate the common cost variation from the special cost variation. So in the control chart, actually we want to easy to visualize analysis. So it's the same. We have the upper control limit here. We have central limit. We have the lower limit. But I want to stress here, if let's say you want to do control chart, all this line is from your process, not from the specification limit or customer requirement. No, this one is from your process itself. Okay, so this one is of why? Because we want to separate the common cost and the special cost variation. So in Minitab, we have a trigger out with the color code. So if let's say you see that the red color here, so meaning that is the out of control. So meaning that now the process is out of control because I have a one red color here outside the control limit. Maybe here is something in control, but they have a pattern inside the control limit here. So they consider also the process is out of control. So the same thing for the attribute, we have a two type. Okay, we have defective, we have a defect. Defective only two options, accept and reject. Defect maybe have more than type of reject. So we have a sale, or maybe you have not fulfilled this requirement requirement 1, requirement 2, and so on. So we consider that the data is the defect. And then for your information in Minitab, we have a P-chart diagnostic. If let's say your subgroup size is a larger, so we have a tool inside the over dispersion or under dispersion. And then if let's say your subgroup is constant, so you can go for the P-chart. If let's say you have a subgroup is a varying, okay, it's not the same, so you can go for the NP-chart. If let's say you want to have a over or under dispersion, you can go for the linear P-chart. Okay, same scope for the defect. We have a U and C chart. Okay, if let's say group is constant, you can go for the U chart. If let's say a varying subgroup, so you can go for the C chart. If let's say your subgroup size a larger, so you can go for the linear U chart. But if let's say you want to know about this diagnostic chart, maybe you can join our training. But for this, explain about this learning chart and then the new chart. Okay, here I have one case study here. The supervisor for our call center wants to evaluate the process for answering customer phone calls. The supervisor record the total number of incoming calls and then the number answered calls for 21 days. The supervisor create the NP chart to monitor the proportion of the calls. So I go to that data set directly. Okay, answer it. This one. So total call for that day is 12. So you see that the total call is not the same because we cannot fix our the total calls. Okay, and then we have the answered call. So we have a 20 out of 250 answer call. So now we're using the NP chart. So where is go to stat, go to control chart, go to the attribute chart. So you choose NP chart. You choose here is the answered call, and then it's the hour sub, and then you click OK. So now you get this one. How you do? Go to stat, go to control chart, go to attribute chart, you choose NP, and then you answer it. Okay, and answer call, and then total call, and you click OK. So you get the NP chart. So since all the sample inside the control limit, so the process in control. Okay, so this portion. Okay, so since if let's say you want to using the assistant, so we available for control chart also for the assistant name button. Okay, so here based on this one, average to it, of course unanswered, the process is in control since all the subgroup are in the control limit. Okay, so Q&A session. If let's say you have any question, please type them into the question box. If let's say I don't have any time to answer it, I will email you. Okay, any question? Yes, you can get recording, or you can subscribe our YouTube channel. Okay. Okay. Any question? How can add the label to the graph? Okay, so if let's say you want to add the add label, so you just you should double click. Okay, you can add, okay, data label or reference line here. Okay, top option. So you just double click, right click. Okay. Okay. What will be the best method in data arrangement prior to analysis? Is there any sample reference? Data arrangement, what do you mean by data arrangement? Okay. Yes, if let's say you want this material, so you can drop your email into the Q&A session box. Okay. Yes, if let's say you want to go for the recording, so you may subscribe our YouTube channel, Minitab Malaysia and Singapore. Okay. Okay. So I will just repeat again. Okay, on this webinar, we want to try working with the qualitative data set. We want to try have different method as usual. Let's say before this, we are always using the measurement data set. So if let's say here is a qualitative data set or category data set, we can do it service quality, but we have a different tools. Okay, just only we go play around with the pie chart, bar chart, and the Pareto chart to identify the main opportunities. And then if let's say you want to know about the association between each variable, if let's say variable is qualitative or categorical, so you can go for the chi-square test. And then if let's say you want to assess about the consistency between your appraiser, okay, between your judgment or reviewer, so you can go for the attribute agreement analysis. So if let's say you want to verify your process is stable over the time or not, so you can go further also the same with the control chart, but different type of control chart, different type of measurement system analysis, different type for the chi-square test, okay, for association, and then maybe different type for the graphical analysis. So no worries if let's say your data is not measurement data but categorical data, you can use the same method, the same step, but different tools only. Okay. And then if let's say you want this material, so you can drop your email in the question and Q&A session and I will send to you. Okay. Okay, so if let's say it doesn't have any question, okay, if let's say it doesn't have any question, so thank you. Spend your time to join our webinar. So if let's say you want to try or buy Minitab, visit www.minitab.com or visit our website www.visits.com, or you can contact us or email us to sales@visit.com or minitab@visit.com. And if let's say you want to get some trade or our Minitab product, please follow us through media social like Facebook and link at the Minitab Malaysia and Singapore. And then if let's say you want to access back our previous webinar, please do not forget to subscribe our YouTube channel, Minitab Malaysia and Singapore. And then really appreciate if you are fill out our survey in order to enhance our webinar session. So see you next time with different topic and stay safe.